Okay, good morning. So I want to teach about radians, but if you remember, I gave you an example from the previous topic, but it was not the best example. So let us start solving this problem, which is related to the previous lesson, and then continue to the new lesson. And because might be you have forgotten the formulas and things like that, let me write them here for you. Do you remember we talked about this? If A is positive and B is not equal to 0, then an expression of this form, A times sine x plus B times cosine x, is equal to square root of A squared plus B squared. Then you will have sine of x plus tangent inverse of B over A. So, and I told you that whatever this x is, if you want to use this formula, whatever this x is, this should be the same x and this should be the same x. So let me underline them. So these are the same x. So this formula in some form will be given to you in the formula sheet, so you can use them. But of course, you need to do some changes here, because this is first of all, this is a mixture of sine and cosine. On the other hand, I have a second power of cosine here. But this should be just a mixture of sine and cosine with the same argument and without any powers. Yes? So, and then might be you have forgotten, there is another formula that is called the half-angle formulas. We had these two things, yes? We learned that sine squared. Let me write it exactly in the way that it is in the book, so you need to be able to translate it yourself. So you had a formula which is 1 minus cosine x over 2. You also had another formula which is 1 plus cosine x over 2. So these we learned when we were learning about the half-angle formulas. Yes? One of these formulas will be necessary for solving this problem. So I will give you a little bit of time to think about this, then I will solve this problem for you, and then immediately we start the new lesson. Okay, now let us go back to this lesson. This lesson, we didn't give a good example. Of course, the example was not wrong, but it was not that related to the topic, because we could solve it in a different way. But let me, hopefully, I have designed it right now, so I think it is okay. Let us use these formulas and this formula to answer this question. So if I want to find, if I want to answer this question using this formula, I have two obstacles in front of me. One is that this angle is 3x, but this angle is 3x over 2. And the other obstacle is that I have second power here. Here I do not have any second powers. So this motivates me to get rid of both these obstacles, yes? So what should I do for the second one? Probably you immediately realize what to do, because the formulas are in front of you, okay? So which one I should do? So I know that cosine squared 3x over 2 is what? I can use this formula and write 1 plus cosine. Okay, can you tell me what should I write in front? What should I write here? What? 3x, yes? Because it means that whatever is here, this one is the double of that one, yes? So because now here I have 3x over 2, if I want to use that formula, I have to write 3x here and then divide it by 2. Yeah. Okay, and then I go and rewrite my function once more. At least this is good. By the way, I got rid of both obstacles simultaneously, yes? Instead of 3x over 2, I have 3x. Instead of power of 2, I have power of 1. So it means that more or less the problem is solved. Yes. So what I need to do, I need to replace what I have. This becomes 5 sine 3x. And then I multiply this expression by 8. So let me write it down. So it becomes 8 multiplied by this expression. 1 plus cosine 3x. And then this, and then minus 6. Okay, this 2 and that 8 are simplified. I get a 4. So it becomes 5 sine 3x. This becomes a 4, but I have to multiply 4 both here and there. So it becomes plus 4 cosine 3x. And then I have minus 6. And then let me simplify the last thing. So it becomes 5 sine 3x plus 4 cosine 3x and then minus 2. So this is the simplified version of my function. Yes? But now hopefully you can see that I can really use the formula but the only thing that I have to be careful is that x everywhere should be replaced by 3x. And of course, I do not have this number in this formula. But I hope that you agree, dealing with this number when it comes to max and mean and the period is very simple. So it doesn't matter, yes? So what can I do? I can continue and write. This A is this number here. This is B, yes? So then it becomes a square root of A squared plus B squared. Yeah, let me write them. And then I will have sine of, what should I write here? 3x, yes? I have to write 3x plus tangent inverse of B over A, 4 over 5. And then what I have written so far is for this part, but I have a negative 2 at the end. And if I want to simplify this a little bit, so this becomes square root of 25 plus 16 is square root of 41. And then I have sine, for simplicity, because this is not a famous number that we have in mind, let me just call it, I don't know, C. And then this becomes plus C. I don't know C. Of course I know C, but not exactly. If I want to know what is the approximate value, this is the exact value, but the approximate value is, I have to put it in the calculator. So these functions we are very familiar with. We worked on about these functions a lot, actually. So this is comparable to this function. Do you remember? A sine of bx plus c plus d. Which, of course, here d is negative. But this is exactly the same function, yes? And we can answer the question. If I ask you what is the amplitude, what's the answer? Square root of 41. But be careful, if I ask you what's the maximum, when I checked my video, sometimes I think I give you this wrong impression. There is no guarantee that the amplitude is also the maximum. It is the maximum if this is 0. But if this is not 0, the maximum is different from the amplitude. So amplitude is the square root of 41, but of course they haven't asked about amplitude. So they have asked about maximum. So what is the maximum of f? The maximum happens when this reaches to its maximum. But sine maximum is 1. So this becomes the square root of 41 minus 2. This is the highest value of the function. And if I ask you what is the minimum value, so it becomes square root of 40, what should I write? The minimum value of sine is negative 1. So it becomes negative 41, negative 2. That's the minimum. And if I ask you what is the period, this period you will get the formula. So this becomes 360 degrees divided by b. So this means that the period is 120 degrees. And I want to tell you something. If a problem is designed so that you have to use this formula, it would be very hard to find an alternative way. So the hard questions usually somehow in trigonometry is involved with this formula, okay? So remember this combination. A combination of a number multiplied by sine, another number multiplied by cosine. So this was a better example. Unfortunately, the example that I designed that time was not related to that example, even though it was also correct. So any questions here? Okay, now let us go back to another topic, which I don't know, in this book they have delayed it so much. So we want to talk about another alternative units in which we want to measure an angle, the size of an angle. The famous one is a degree. The other one, which is actually from now on, I would say 99% I will use radians. And in the university text, I would say nearly 100% they use radians. And then we will talk a little bit what is the benefit of using radians over degrees. Okay, but first of all, let me try to ask your opinion. What is the meaning of 1 degree? When I say that an angle is 1 degree, what is the meaning? Consider a circle and answer that question in a circle. What is the meaning that if I have 1 degree? Yes?
360 part of the circle.
So it means that, yes, yeah, exactly. So it means that what you do, if I want to talk about degrees, so here I will take the circumference of my circle and then I divide this into, of course I'm exaggerating because I don't know, I have to divide this into 330 equal pieces. Yes, it's much, probably less than that. But anyway, assume that this will continue and then at the end you will get 360 equal pieces. And then you choose 2 consecutive points, for example this one and that one, and then you connect it to the center of the circle. Then what you get is called 1 degree. Yes? So it's a tiny bit of angle. Yes? It's, of course, there is something a little bit, we need to address a question. I want to actually ignore that, but this question shouldn't depend on the size of the circle. Yes? Do you think that I draw a bigger circle and I divide it into 360 pieces, equally pieces, and then if I connect it to the center, yes, the size of the angle shouldn't change. If it changes, it means that this is not a good unit because it depends to the circle itself. It doesn't mean it's not a good unit, but then I have to tell in which circle do this to get 1 degree. But I am telling that draw just one arbitrary circle and do this, you will get 1 degree. Yes? Is that clear? So that's the meaning of 1 degree. The definition of a radian is a little bit more involved, but it is also very simple. So what you do for finding a radian, let me define it exactly in this picture. So assume that you have a piece of thread or string or something, and then you take that thread and then cut it exactly in a way that the length of that thread is exactly equal to the radius of the circle itself. Yes, so I have a piece of thread in my hand, it's flexible, but if I just make it, I don't know, stretched, how do you say it in English? Do you know what I mean? If you make it this, what's the word in English? Tough? No? No? No, I don't know. Make it, so yeah, just stretch it so that it's a straight line. Then what happens? The length of that piece of thread is equal to the size of the radius of that circle. So now you have that piece of thread in your hand. What you do, I don't know, needle it somewhere on the circumference and try to adjust that piece of thread in a way that it overlaps exactly with this part of your circle. Okay? So for example, I don't know, I cannot imagine it that much, but so you can just come here, for example, yes, and then the thread is finished here. For example, if I ask you, is from here to here equal to the radius? No. Okay, it's a little bit shorter than the radius because this green thread is equal to the radius, this length that I am measuring on this curved, on this bended curve. Okay, so this is not the radius, but the length of it, when I stretch it and make it a straight line, it becomes equal to the radius of the circle. Then I take this point and I connect it here and here. This angle is 1 radian. Yes? So this is the meaning. And then you have to use the word RAD if you mean radian. If you want to emphasize, there is no shortcut like that. You have to write. So this is the meaning of 1 radian. Intuitively, do you think radian is bigger or degree is bigger? Do you think 1 radian is bigger or 1 degree? Of course, this picture is far away from reality, but I don't think it is hard to realize that radian is bigger. Yes? But how much bigger? Because this is a very sensible question. Is that understandable? Because when we have 2 units for measuring the length, for example, meters and yard. Okay? So what is the natural question? So for us, if I give you, the length of this table is 1 foot or 1 yard, we have a hard time to understand what is the length unless we know the conversion factor. And I understand how can I go from foot to meters or the other way around. Yes? So that's a sensible question. To answer this question, you need to answer this question. 1 foot is equal meter. Foot and meter are units for the length. So I need to understand what is the connection between 1 foot and 1 meter. The same question is sensible here. I have degree, I have degree, and I have radian. So because degree is more familiar for us, so I need to answer this question. Yes, if I can answer this question, then I have the converting factor. So how can I answer this question? The definition of the radian is a little bit odd. This is why it is not immediately seen what is the conversion formula. But let me ask you another question. Can you tell me how many degrees will fit in the whole circle? How many degrees will fit in the whole circle? Yes? 60. Now, the same question I want to ask about radians. How many radians will fit in the full circle? If we can answer that question, then the conversion factor becomes immediately clear. Yes, Jonathan? How do you know that? Yes, it is 2 pi. Yes? Yes, exactly. So that's the answer. So if I ask you, if I have this pen, if I give you the length of this pen, and if I give you the length of this table, and if I ask you how many of these pens can fit into this length, what do? You need to divide the length of the table by the length of this one, yes? And that's exactly the same story. If I ask you, do you know how much is the length of the circumference? If you have forgotten, the formula is 2 pi, the famous pi number, multiplied by the radius of the circle, yes? If the radius length is r. So that is the formula for the circumference yes, of the circle. But I just told you that I want to see how many of these green lines I can fit inside this circumference. So that is exactly the same question. This length divided by this length. Here, from here, for example, going back to itself is 2 pi r centimeters, for example. Yes? And then this length is r centimeters. I want to see how many of them will be in this circle. So what should I do? I need to divide it by r. Is that division understandable? And if you do that, this r and that r are cancelled, and what is left is 2 pi. So the answer is that in one full circle there are 2 pi radians. Okay? This is a little bit strange because at the end we will not know how many radians are there. Why? Because we don't know the exact value of pi. Yes? If I ask you how many radians are in the circle, you can say 2 pi, but who knows pi? Pi is 3.1415 until infinity, yes? So we cannot exactly answer this question, but pi symbol means exactly that number. So that is 2 pi. So this is an irrational number. So in the case of a degree, if I ask you how many degrees are there, you just say 360, and 360 is just a very nice number. Yes, it's 360. But if I ask you the same question about the radians, you will tell me 2 pi radians, and that's exactly the number that we want. Okay, so we learned this. In one circle, okay, so in one circle we learned that there are 2 pi radians. So it means that, now how can I answer how much is 1 radian then? I would say that if my 360 degrees from angle point of view is the size of the same angle 2 pi radians. Now I hope that this is understandable now, yes? 360 degrees is the full circle on the one hand measured in degrees, and the same angle measured in radians according to this argument is 2 pi radians. So they have to be the same, yes? 360 degrees is the same size of the angle as 2 pi radians. Yes, is that understandable? Okay, but then I want to know what is 1 radian. So I have to get rid of this 2 pi and make it 1.
Yes.
So I should divide by
2 pi.
2 pi here and 2 pi there.
Yes.
Then if I divide this by that, it becomes 180 over pi degrees is equal to 1 radian. Yes, so 1 radian, I can just clean this. I would prefer to put a brackets here. So I would write 180 divided by pi, whatever it is, degree. Yes? Of course, this is also good to write 180 degrees divided by pi, because that's exactly the same thing. It doesn't matter actually. But if you want to get a feeling, can you tell me, this is not a very sensible number. If I want to get a feeling how big a radian is, what should I do? I need to divide 180 by which number? 3.14 or something. So let us just do that. I want to work with the exact formulas all the time, but if I want to have a feeling, if I remember, it should be around 57 degrees or something. Yes, is that right?
Yes.
Okay, did you calculate? What's the number?
57.29.
57.29 degrees approximately. So your intuition was correct. It is approximately 57 times larger than a degree. Yes? Okay, so that is the meaning of the radian. So that is easy. But now working. Before doing more, let us do some famous angles. So for example, what is, if I want to have 30 degrees expressed in radians, so what would be the answer? So what I can do, I can say that 30 degrees is equal, I want to be a little bit, I want to write all the details so that you understand. 30 degrees means 30 times 1 degree. That's the meaning, yes? But we just learned, oh, by the way, I need the converting factor the other way around. So can you tell me what is 1 degree now in radians? 1 radian is equal to this in degrees. What is 1 degree then? I want to make this instead of this number 1. So I need to multiply by the reciprocal, yes? So it becomes pi over 180, yes? So these are the formulas. I don't know, some of them are in the book, but if there's note, you can write them down in your notebook. And I think even if you forget, you just imagine 1 full circle is 360 degrees, and just by this calculation, you realize that's 1 degree. Okay, so we can do that. I can write 30 degrees is equal to 30 times 1 degrees. And then I would write 30 instead of 1 degree. I can use that formula. So it's pi over 180 radians. And then of course I can simplify them. It becomes pi over 6 radians. So 30 degrees measured in radians, it would be pi over 6 radians. This is the exact value. If I want the approximate value, what should I put instead of pi? 3.14 to 15 something. And then I would get an approximate value. But keep it in that way. Yes? So from now on, if you want to use your calculator, you have to be very careful because they are quite different. So you need to know that if you are working in degrees, you have to set up your calculator in degrees mode. And if you are working in radians, you have to set it up in the radian mode. And you need to learn how to do that in your own calculator. So is there any question here? Okay, so I have heard about this one. So that people say that when you go back, if you want to go back, simply put 180 instead of pi, and then you get the answer. So that's working, yes? If I, instead of pi, I put 180 divided by 6, it becomes 30, yes? I don't like it. Of course, I like it if you understand the problems, the loopholes, yes? Pi, if I ask you what is pi, I have heard many students after working in trigonometry, when I ask them what is pi, they say 180. Okay? Because of this conversion factor. They have learned that when they want to go from radian to degrees, the easiest and simplest way is to replace pi with 180, and it will always give you the answer, the right answer. But it doesn't mean that pi is 180. Pi is always 3.14 or something. The correct statement is that pi radian is equivalent to 180 degrees. This is why you can replace pi radians with 180 degrees. So if you understand that, just use it because it's a very quick way of doing it. But the correct statement is not pi is 180. The correct statement, the complete statement is pi radians is equivalent to 180 degrees. Then it means that if you want to do this calculation in your head immediately, it seems that you are replacing pi with 180. Okay, so be careful about that. Okay, so if I ask you what are the famous angles, by the way? Let us just check a little bit. So because you need to get used to this unit, for me it's very hard to work with degrees, so this is why I was confused when I was working with GeoGebra in degrees. I have to adjust a lot of things, but GeoGebra is automatically in the Radian mode. So here, if I ask you what is 0, so let me just, by the way, you know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees again. So let me write all of these things in radians. So what is the radian version of this? 0 radian, yes? So what is this one? 90 degrees is equal to? You can imagine, pi is equivalent to 180, so that method is good. But I want 90 degrees, so I have to divide pi by 2, yes? But understand, pi is not 180. So it is pi over 2 radians. And then what is this one now? Yes? Pi radians, yes. And then what is this one? So this is 90, this is 270. It is 3 times larger than that. So in radian it should be also the same. Yes? And then if I go back, it becomes 2 pi radian again here. Yes? Is that clear? So for example, what is 45 degrees in radian?
Pi over 4.
Pi over 4, yes? Because 45 is half of 90. If I divide pi over 2 with another 2, it becomes pi over 4. So 445 degrees is equivalent to saying that pi over 4. Yes? Another thing that is very important, from now on, I have to be careful in the exams and every questions that I'm asking. If I mean degree, I have to put that little circle on top. If I don't, by default, it is in radians. And it matters a lot. if you have your calculators available, if I ask you to calculate sine of 1, you need to switch to radian modes, to the radian mode. If I ask you, if I want to give you in degree, I have to respect and put this on top. If I don't put it on top, by default it is radian. Yes, and then just do this calculation. There is a very big difference between these two. Switch to radian mode. It's better to learn in your calculator how to do it, and then calculate this and remember the some numbers, and then do the same thing with degrees, and you see that they differ a lot. And whenever you want to see if it is in the radian mode or not, you can, for example, punch this. If it returns you to number 1, it means that this is in the degree mode. Yes? Yeah, I think it's good to learn that. If you don't have your calculator available with you right now, but yeah. And then remember, every mathematics books by default is in radian, unless they mention it. Of course, in high school it's the other way around. But if you go higher, they always think about radians. And it is very important for us when we go to the notion of derivative, because the formula that we get for the derivative of sine function would be different from the formula that we get for the derivative of sine if I am working in degree or I am working in radians. Yes? We will work in radians, but we need to understand what is going on. Any questions here? Because actually, when I write sine of 1, I am calculating sine of 1 radian. 1 radian is about 57 degrees. Yes? So here, this is the calculator is giving the sine for around an angle around 57. Of course, this is bigger than this one. They should be different. Yes? Yeah. So be careful. If I write this, don't ask me is it in radian mode or degree mode. I will not answer. You need to know. Yes? Okay. And in principle, I have seen, I don't know, I haven't checked your book. Even if you write this, so in principle, we should write every detail here. So this is a pure number, but this cannot be a pure number. Yes, but by the way, if I add two quantities, x and y, if they are some pure number that's different, you can add them. But if this is a length, this should also be a length. Otherwise, you cannot add them. Yes, you cannot add length to area. Yes, but you can multiply numbers with different dimensions. So I can, if I want to multiply, this can be a length, this can be an area, and of course, if you multiply them, it becomes a volume. Yes. So this is possible. For adding or subtracting, you should have the same dimension. So in principle, if you see something before this lesson, do you remember we talked about sine of this? Yes, in principle, I have to emphasize that this is in degrees, but we didn't know about radians at that time, so I didn't emphasize. Now I'm asking you, if I want to emphasize, which one of these numbers have to be in degree? Yes, x should be in degrees. Is there any necessity for b to be in degrees or whatever? No, because this is multiplying. It can be anything. But for c, okay, but let me tell you, can this be any number of any dimensions? Are we finished? Oh, okay. Can this one be any number with any dimensions? Yes or no? Yes. Yes or no? No.
Why?
The reason is that if this is not there, yes, it can be anything.
Ah.
Okay, not anything, by the way. There is a deeper understanding. So let us forget about sine.
Okay.
Okay. This cannot be any number, because if I multiply any number with its own dimension, for example, if this is a length, yes? If this is a length, then this is a degree. The unit here would be length degrees. Yes? So this will affect this one here. Then this has to be a length degrees. Yes? If I write this and I give you this is the dimension of length, this is wrong. Is that understandable? Unless there is a hidden one here with unit length. Yes? So I just want to know, I want you to understand that if you are adding things, they have to be of the same units. Otherwise you cannot. Yes? So this is very important to know. And this is the main reason that we want to work with radians, because we don't care. Radians are pure numbers. You don't need to be worried about units or whatever. Yes? So you can just simply write sine of 1. If I ask you, is this 1 different from the 1 on the x-axis? No, that's the same 1 on the x-axis. Yes? So this is the reason that we want to work with radians. Yes, they are dimensionless. They are pure numbers. Okay? So when I say sine of 1, you cannot say that this is definitely an angle. No. This is definitely a number, and that is 1. Yes? But if you want to understand what is going on, you can say that this 1 can be interpreted as an angle. I am calculating the sine of an angle. The reason is that in more advanced mathematics, you don't need to define sine and cosine for angles. You can define sine and cosine for numbers. Okay, and that's so sine of 1 makes sense. Later you will learn that sine. So by the way, the calculator is not doing the angles for you. If I punch this in the calculator will not draw an angle with 1 radians and then go and find the x coordinates. I found it here, it's you. No, it's calculating in a different way. And this is sine of x. They are actually calculating what is called a Taylor expansion of a function. So sine of x is x minus x to the power of 3 divided by 6 plus x to the power of 5 divided by 120, and this series, infinite series, continues. Okay, and so then if I want to calculate sine of 1, I put 1 here and I calculate that one. Okay, so let us, by the way, check this one. But of course this series continues forever. If I take 1 term, my error would be bigger. If I take 2 terms, I will be closer to the real value. If I take 3 terms, I will be closer. So what calculator actually does, it calculates up to the point that the display will let it to calculate. So for example, if I calculate sine of 1, by the way, it becomes according to, if I want to ignore, so it becomes 1 minus 1 over 6 plus 1 over 120, and then you can continue this list. Okay? And of course, finding the sum is not that easy, so you need to think about these problems. How can I add infinitely many? But by the way, can you calculate this up to with your calculator? Up to this point. 1 minus 1 over 6 plus 1 over 1 over 20. 120. And give me the decimal points for that. So this one is minus, the next one is plus. What?
0.84.
0.84, yes? You calculated these 3 fractions, yes? Now can you is it in Radian mode, your calculator?
Yes.
Okay, now can you calculate sine of 1?
It's 0.84.
Yeah, it's 0.84, yes? 0.84 with 2 decimal points, yes? So it means that if I stop up to here, up to 2 decimal points, I haven't made any errors.
Wow.
But if you continue this fraction, so and then can you give me the other values here, some values? For sine of 1 is? So this one, sine of 1, 84, what?
14.
14 more?
7.
7 more?
0.
Okay. And then here, add this one and give me more details here.
16 of them, 6.
16 after
Yes,
this one. So you see 16, the deviation appears on the fourth digit. So if you need precision up to 3 digits, this is enough. That is the sign. This is the way that the calculator calculates sine. It doesn't know about angles or whatever. You just punch. This is the formula actually in the calculator. And then you can just program. This is not hard. But program it, the calculator, go and draw a line and things like that. This is not possible. But this is the way that the calculator actually calculates this. And now you realize this doesn't make sense at all if x has some dimensions. Whatever x, so assume that this has a dimension d. Then this quantity would be of which dimension? D. But this quantity is of dimension d to the 3. And then I cannot subtract them. The only way that I can subtract them is having the same dimensions. But because these powers are going higher and higher, I cannot make the dimensions the same unless x itself is dimensionless. Is that understandable? So it is crucial to work in radians, not just a fantasy. Yes? So you have to think about radians essential. So this is why we work in radians. And when I write sine of 1, you don't need to think all the time about angles. This is sine of number 1. Pure mathematics famous unit number 1. Yes? That's it. And when I ask you what is the sine, so you can calculate sine and cosine of any number instead of any angle. Is that understandable? Of course, there is a consistency between angle interpretation and the number interpretation. Yes, please.
But, okay, so if I put in like sine of 180,
yes,
shouldn't I get pi radians?
No,
Because,
no.
Because I'm thinking of the units.
No, according to this formula, if you write 180, you are calculating sine of 180 radians. And then if you want to see how much is it in degrees, so you can then calculate it in degrees. So you see, if you write sine of 180 degrees, you cannot use this formula. Because this becomes degree to power 3. And then a quantity of unit degree cannot be added or subtracted from a quantity of that. But if you are asking, can I use this formula to calculate this? The answer is yes. First, you have to reduce this to the radian mode. So you would say that 180 degrees is equal to pi radians, and pi radians is a pure number. So if you want to calculate sine of 180, you can put pi there. And then this is very strange. If I ask you what is the sum of this series if I continue forever, the answer is 0. Without knowing what is, so I don't know how to calculate this. Yes? Because if I want to calculate, I have to, what do you want? Even if you have supercomputer, it's useless. Because if you want to find that, you have to put the exact value for pi. We don't know that exact value. But from calculus, we understand that this series is 0. So we are discovering the formulas for series from connecting different ideas from different parts together. But this is important. You need to understand what is going on. Is that clear? Okay, at least you have a good understanding of what is going on in your calculator or in GeoGebra. So from now on, don't think that you have to have the notion of an angle to talk about sine or cosine. You can talk about sine and cosine of numbers. But if you want to interpret it as the angle, it means that that number should be expressed in radians. If you don't like radians, you have to change that radians to degrees. That is also compatible with what we have talked about here. This is the way that you need to think. Yes? And this is why when I want to work with radians, I really don't need to care about writing units and things like that. I can just calculate them, whatever it is. That's just a number. Yes? Is that clear? Okay. And by the way, these kinds of expansions, they are called Taylor expansions. So it's not, by the way, there is a proof for that. Why the sign that we defined in high school in this way gives me the same formula you see for the same sign. We do not have two sine functions. Sine function is the same function. So we learned about sine function in the high school. You'll learn about the sine in the university, something like this. But this will calculate the same sign that you like to calculate, yes, in the high school. It's not a different sign. Yes, I would say it's a generalization of the concept of the sine function. And whatever you have, they should be dimensionless. For example, if I give you e to the power of, do you remember e, yes?
Yes.
If I write e to the power of x, this cannot be a number with a dimension on top. I cannot write that e to the power of L, where L is the length of this table. It's not meaningless. But if the length of this table is 2 meters, then e to power 2, just 2, not 2 meters, is meaningful. Yes? So on top you cannot put a number with units. Yes? So be careful about these things. Of course, might be they are not that important for you, but yes. Let us go back to our lesson. Okay, so let me ask you one question before going to our lesson, because that's important. Let me give you an angle theta. Yes? Is this meaningful or meaningless? Yes?
If you express theta in radians, both separately and with sine, then it should be meaningful.
Yeah, it's meaningful. Yes. So theta, if I write it in this way from now on, if I put degrees, this is wrong. This is not meaningful. Why it's not meaningful? Is this, by the way, let us play around with this a little bit. This is nice, yes? Which one? I don't know, for example, which one makes sense? If any, of course. Both of them, this one and that one, none of them. These are the 4 possible combinations that we can think of, yes? Do you want to answer? Okay, let us answer. Is this one meaningful?
No.
Why?
Because you can't, sine of theta degrees is a number.
Is a pure dimensionless number.
Yeah. And
when I say sine of 30 degrees, you answer me 0.5. You don't say 0.5 something. That's just 0.5.
Yes.
Yes? And then I am measuring this in degrees. So this combination is meaningless. Because the output of this is a pure number, but you have something in degrees, you cannot subtract it. Yes? So it's meaningless. What about this one?
Okay.
Also, when I write it in this way, you have to express it in radians, but who cares? The final answer is a number. So this is also meaningless. What about this one? Number 3.
it's meaningful.
It's meaningful now, yes? Because when I write it in this way, I mean theta is a number, and this sine of theta degrees are also a number, and then I'm subtracting 2 numbers. Yes? And then when I write this in this way,
It's also meaningful.
it's also meaningful. But are the answers the same? No. Because sine in theta degrees is different from sine theta in radians. The numbers are different even though both of them are meaningful. Is that understandable? Okay. Now let us do something very important, probably also needed in physics. I don't know, might be have already done that. And that is, how can I find the length, arc length? So what I mean, I have a circle, and I give you the radius. The radius is r, and I give you an arc. This is an arc, yes. And then this arc has a length. What do I mean by an arc length? It means that if I have my famous thread in my hand, I put my thread here, and whenever it is finished, I cut it, and I stretch it, and I measure the length. That is called the arc length. Yes? So don't get confused. From here to here is the chord length. Yes? This one is arc. If I connect these two, this is called a chord. Yes? So this one is a chord, this one is an arc. And then chord length, you don't have any problems with. It is just a line segment. You measure that. But when I say an arc length, it means that you can imagine in this way. If I have that thread and I overlap my thread with this one and then cut it and stretch it so that it becomes stiff, then I measure the length. That is called the arc length. Yes? Now I want to ask you something. Can you find a formula for the arc length? This is also in the book. And it's also very important in physics. So we want to find the length of this. What do you think this length will depend on? Do you think if I make the circle smaller or bigger, it will affect the length? Yes. The length will be affected. Good. If I make this should depend on R definitely. One more quantity. So you consider this angle. This is called a central angle. If this angle I make it smaller or bigger, do you think this will affect this length? Yes. So it means it is clear the arc length should depend on both R and the angle. Okay, now can you find the formula? So let us work with degrees that you are more familiar with. Let me give you theta degrees for the time being, and I give you the length. I don't know. I think in Swedish it's called båge or something. Oh, yeah. So this is the way that they call it B, but in English one it's called L. Okay, so let me just use L. And this length is R. Okay, if I give you R, if I give you this angle, can you invent a formula so that I can measure L? It's not hard, it's just a simple. Okay, so the word English word, I remember there was an English word I was looking for, is this word. Yeah. Yes. And this means stretched tight. Okay. This was the word that I was looking for. I remember something. So what can I do now? I would say that if this angle is 360 degrees, I know the answer. Yes? Yes?
Is it 360 over theta times 2 times
pi r? Yeah, exactly. That's just simple, yes? What we say is that if this angle is 360 degrees, I know the formula because it becomes the whole circumference. Now, I do not have the whole angle, I have one portion of that. What is that portion? It is theta degrees divided by, yes, multiplied by 2 pi r. Yes? Is that understandable for everyone? So that would be the length here. Let me ask you one thing. What is the dimension of this fraction? Is this dimensionless or it has some dimensions? Yes?
It's dimensionless when divided.
Yes, because this is in degrees and this is also in degrees. I am dividing two quantities with degrees, so it's dimensionless. 2 and pi are also dimensionless, but r has dimension of length. So it means that the whole quantity has dimension of length, and this also has dimension of length, so it's compatible. Yes? Not only compatible, but it's also the correct formula. But let me now simplify. Can I simplify this a little bit more? Yes. This 2 and that 1 will be cancelled. So it becomes theta degrees divided by 180 times pi times r. Okay, but now you will see another benefit of working in radians. Let me solve the same problem, but let me change it to radians. I do not write something, it means it's in radians. Let me solve the problem in radians. How do you solve the problem? The same story. But this time, you divide theta by what, can you tell me? And then multiply it by 2 pi r, yes? The same idea, but in a different unit. So what should I write below here? Yes, 2 pi, yes? 2 pi. And now interesting thing is that this one and that one are gone. And then what you get is just simple formula that you have in physics. L is r theta. Yes? So in physics, automatically you are always working in radians, even they don't mention it. Yes?
So that is for radians.
That is what?
For radians.
This is always for, yes. Don't worry. If I don't put something for the angle, it's always in radians. So just get used to that convention. So this is a very important formula, so I really want you to learn that. By the way, so let us just talk a little bit about this. So I don't know, might be you have seen this formula. I don't know, have you seen this formula in physics?
Yes. Yes.
Okay, so that's this formula.
Yeah.
How? You take the derivative from both sides of that. Yes. So let me. I don't want to confuse you that much here. But omega, so this letter that I'm using here is coincidentally the same letter here. No, but that is correct actually. Okay, so I don't know. You have studied a little bit of derivative. If I start differentiating both sides, this is just simple. You can use your math 3C knowledge. So you have L. Of course, I think in Swedish system, in physics, you write S.
Yes.
Am I right? So then you write R theta, yes?
Yes.
And now you differentiate this. The derivative of S becomes, what is the derivative of S? The speed.
Yes.
So this is why if you take the derivative, it becomes V. But you want to differentiate this one. R is a constant. You don't differentiate it. It becomes R. But the derivative of omega means how fast omega is. Sorry, the derivative of theta is that angle. It is telling you the rate of change that this angle is changing.
Yes.
But that is called the angular velocity. Yes? So this is why this becomes omega. Okay, so that is the formula that you have it in physics.
Yes.
And that's exactly coming from this relation. Yes? So it means that you are automatically working in radians in physics, not in degrees. Because the formula for degrees carries this ugly coefficient. Yes? Is that clear?
Yeah.
Okay, now another question I want to ask you. How can I find this area? If I connect these 2 points, this part, by the way, yes, no, let me just clean this one. This one is called a sector.
Yes.
Okay, so this is the English word, I don't know for the students, but okay, that's the sector. How can I find the area of the sector? That's also in the book. So how can I find the area? Exactly the same method. Yes? Do you agree? Yes. So instead of area, I don't know which one we can use. Let me use capital letter A for area. And then instead of this one, I can of course write the same thing. But instead of multiplying by 2 pi r, this time I will multiply it by the area of the full circle. Yes? That's the same argument. But the area for the full circle is this. And nothing can be simplified. We have to live with this ugly coefficient. But let us go to the Radian mode. Yes? What happens in the radian mode? So A becomes equal to theta divided by 2 pi multiplied by pi r squared. But this pi will cancel that pi, so I get A is equal to 1 over 2 r squared theta. Yes? So this is the formula for the area of the sector if theta, the central angle, is measured in radians. If it is measured in degrees, we have to have this, which of course this is much more beautiful than that. Yes? Yeah. Okay, let me now ask you one question. Can you calculate the area of this triangle for me? I give you this as theta, and then I connect these 2 points, and I ask you to calculate the area of this triangle, not the sector. Or, if you want to, I can also ask to calculate this the area of the red part, which is not called the sector. What is the area of the red part? Of course, it is clear that if you can calculate the area of the triangle, you can also immediately answer the area of the red part, because you can subtract it from the area of a sector. Yes? That is easy. So the only point is that how can I calculate the area? And I haven't put the degree sign here. It means it is in radians. So it is R. It is R. I don't know how many of you remember about the sine formula, the area formula in Math 3C. So if you have, it's an extremely important formula. This is one of those formulas that we will not repeat in our lesson. So if I have A, B, C, if I want to find the area, so let me write area S this time. By the way, S is more standard. So S is 1 over 2, the length of this, which is C, the length of this, which is B, and then multiplied by the sine of the angle between them. This is called the area formula. You had it in Math 3C. So now if I want to find the area of this triangle, S becomes equal to 1 over 2, this side R, multiplied by that side, which is also R, multiplied by the sine of this angle, yes, which is equal to 1 over 2 r squared sine theta. This is the area of the triangle. So if I give you the angle, if I give you the radius, you can find the area of that one, but the area of this part becomes what? 1 over 2 r squared theta minus 1 over 2 r squared sine theta. Agree? Yes. And then let us make it more beautiful by writing this. And then you see that combination pops out actually. Theta minus sine theta. This is the reason that I ask you about if they are meaningful or meaningless, because I remember this formula. So this is the area. This is the area of the red part. If I give you the angle, I don't need to mention that this is expressed in radians. Yes? You can of course write it in degrees, but this is in radians. Any questions? Yes or no? Okay, so we don't have that much time, but what we need to do, this is the bad point, you have to adjust whatever you learned in degrees with what you learned today in radians. Okay? I know that this is a little bit a torture of your soul, but sooner you have to go to that one. So from now on, mainly, I will work with radians, yes? But occasionally we go back to degrees sometimes, okay? Yeah, not to forget about our old friend totally, yes, degrees. Okay, so I think it's good to stop here and then we continue the last part of the lesson next week. Yes, thank you. No questions, by the way? No questions? Thank you. Have a nice weekend.